All atoms of a particular element have the same atomic number. This means that they all have the same number of protons. But sometimes you can find heavy atoms of a particular element. These atoms have a higher mass number. The mass number is equal to the number of protons plus the number of neutrons. We can ignore the electrons as their mass is so tiny. If the number of protons always stays the same in a particular element and we are ignoring the mass of electrons, it must mean the number of neutrons is causing the difference in mass. Atoms of the same element with a different mass number are known as isotopes. They are defined as atoms of an element which have the same number of protons but a different number of neutrons. If we look at carbon and nitrogen, are they isotopes? They have different mass numbers, but they also have a different number of protons. Therefore, they are not isotopes. They are completely different elements. Different isotopes of elements do not have separate positions on the periodic table. They occupy the same spot because they have the same number of protons. What about carbon-12 and carbon-14? Both carbon-12 and carbon-14 have the same atomic number, which means they have the same number of protons, but they have different masses. Carbon-12 has a mass of 12 and 6 protons. Remember, mass number equals protons plus neutrons. So we can rearrange this formula to give us neutrons equals mass number minus protons. 12 minus 6 equals 6. Therefore, it has 6 neutrons. Carbon-14 has a mass of 14, but it still only has 6 protons. Mass number equals protons plus neutrons. Rearrange. Neutrons equals mass number minus protons. 14 minus 6 equals 8. Therefore, carbon-14 has 8 neutrons. Carbon-12 and carbon-14 are not the only examples of isotopes. There are many more, such as hydrogen, deuterium, tritium, and chlorine-35 and chlorine-37. Isotopes only differ in their number of neutrons and their mass. Their chemical properties are exactly the same because neutrons have no effect on an element's chemical behavior. This is controlled by electrons, which we will discuss in another video. So isotopes are atoms of the same element with the same number of protons but a different number of neutrons. They have different masses, but their chemical properties are exactly the same.
Disa elemente ekzistojnë në natyrë me vetëm një izotop, si për shembull fluori, alumini, kobalti dhe ari janë shembuj të këtyre elementeve. Disa të tjerë janë të përbërë nga përzierja e disa izotopeve. Për shembull, njihen 3 izotopet e hidrogjenit. Bërthamat e izotopeve të hidrogjenit përmbajnë nga një proton, kurse 0, 1 ose 2 neutrone secila. Izotopet e hidrogjenit janë të njohura me emrat hidrogjeni i rëndomt ose protiumi, deuteriumi dhe tritiumi. Karboni natyror përmban 3 izotope. Izotopin e karbonit 12 me pjesëmarrje prej 99%, izotopin e karbonit 13 me pjesëmarrje prej 1% dhe izotopin e karbonit 14 në formë të gjurmëve radioaktive, i cili përdoret në datimin arkeologjik. Urani natyror është i përbërë nga 3 izotope. Të gjitha janë radioaktive dhe zbërthejnë nga dalë duke emituar ose liruar grimcat alfa. Simboli i izotopit të uranit 235 tregon se bërthame e tij përmban 92 protone dhe 143 neutrone.